Unit 1 review is brought to you by a generous donation by the Umbrella Corporation. Our business is life itself, and viewers like you. All right, it's time for final review. That's right, and this part is Unit 1. So in Unit 1, we learned about classifying numbers first, and these were the types of numbers that we learned about. Natural numbers, which were the counting numbers, 1, 2, 3, 4, 5, pretty much any number that is a whole number after 0. Speaking of whole numbers, our next number was, in fact, whole numbers, which are all those counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but we also add in 0. So 0, 1, 2, 3, 4, 5. Then we have integers. Integers are all those whole numbers, but then also the opposites of them. So like in addition to 1, there's -1. In addition to 2, -2, 3, -3. So we have natural numbers, whole numbers, and integers. Now we're going to get to the rational numbers. Rational numbers in this case are numbers that are like integers, fractions, terminating decimals, and repeating decimals. So it's all the integers that we just talked about, plus any sort of decimal or fraction, any part of a number that's easily defined. So 1/3, 0.4 repeating, anything like that. Then we have what are called irrational numbers. Those irrational numbers are just non-repeating decimals. So pi is an irrational number. E, which we'll be learning about later this year, that is an irrational number. All of those non-repeating decimals. The square root of 2 is irrational. Finally, we have what we call real numbers. Real numbers end up being all of the rational numbers and all of the irrational numbers combined. Every number that truly exists is real. And if we have the numbers that are real, we have to have one other type, which is imaginary. Now, we talk about imaginary later this year, but basically, imaginary numbers are square roots of negative numbers, or I. So now we're going to talk about the opposite and reciprocal real quick, in case you've forgotten. The opposite of any number A is -A. So if I said 2, the opposite of 2 is -2, or the opposite of -5 would be +5. Basically, it's the negative version. So if we start out with a negative, it becomes positive. If we start out with a positive, it becomes negative. Now we have to deal with the reciprocal. The reciprocal of any number A is 1/A. Meaning, if we say 2, the reciprocal is 1/2. Now when we talk about fractions, like say 3/4, that means that you switch the numerator and the denominator. So 3/4 becomes 4/3. All right, so now we're going to talk about function notation. If we write a function as f of x equals 3x plus 2, then if I say f of 5, then that means that where we see the letter x, we replace it with 5. So f of 5 would be 3 times 5, or 15, plus 2, which is 17. Now we have one last thing to talk about in this section, and that is parent functions. So the first parent that we're going to talk about is linear. It looks like a line. Here's all the information. The big thing to know is the equation, which is y equals x. Then we have absolute value. It looks like a v, and the equation is y equals the absolute value of v. Next we have quadratic, y equals x squared, and it looks like a u. And those are the ones we talk about this semester. Now we also have square root, exponential, and logarithmic, as well as reciprocal and cubic that we're going to talk about next semester. So, to talk about the more generic rules, we have transformations. Now, it's important to note, I'm not going to discuss transformations between each of the individual types. So in other words, when we talk about absolute value, there is no rediscussion of transformations. If you need to know about transformations, come back here. So if we're given the parent function f of x, the transformation of this function is given by a times f of b of x minus h plus k. So first we're talking about a. A affects the y, it's a vertical stretch, compression, or reflection. So if the number is larger than 1, it ends up being a stretch. So if I say 2, it becomes stretched out like I'm pulling it up and down. Compression, that's like I'm pushing in a sandwich. That's if it's less than 1. And I'm talking about like a 0.5 or a negative 0.5. When I say greater than 1, I mean like a 5 or a negative 5. Finally, if it is negative, though, the big thing that you need to know is that means it's a reflection. So here are some examples. I've just written them in all the different types. So notice how it looks whenever A is there. Some of these you won't be able to tell that much of a difference, but you should notice that the 2 is outside of the equation on each of these. Now we're going to talk about the letter B. B ends up affecting our x value, or horizontal, and so it ends up becoming a stretch, compression, or reflection again. But the big thing to know is with B and H, it ends up doing the opposite or the reciprocal of what you would expect. So in the case of B, it's the reciprocal. So if I say that x is less than 1, it's going to end up being a stretch now. So 1/2 becomes a stretch by a factor of 2, whereas 2 becomes a compression by a factor of 1/2. Finally, if it's negative, it remains a reflection. So let's look at some examples here. Now, you'll notice whenever it comes to linear, I listed that as the same. That's because if I put parentheses around a linear, it's not going to change anything. So I didn't put them. But besides that, everything else changed. You should really look out for things like parentheses, because those are really going to affect stuff. Now we're going to talk about H. It affects X. If I subtract, we actually move right, and if I add, we move left. It does the opposite of what you would expect because we're using the opposite value. So if I say plus 5, we actually move left 5. If I say minus 5, we move right 5. Here's what it looks like in this case when we move right 2. So notice a few things. Notice where things are placed. Now we're going to talk about K. K affects Y, and if I add, it goes up. If I subtract, it goes down, just like you would expect. So notice how it looks on these.